7.3 day 2. In this section of the notes, we're going to be graphing logarithmic functions. So let's say we have this graph, y equals log base 3 of x. I'm going to start off by writing this in exponential form. So it's 3 raised to this power. Normally the equal sign is over here. Okay, so 3 raised to that y power equals x. So normally we plug in x's and we figure out what the y is. For this problem, we're going to do the opposite. It's easier to plug in y's to figure out the x. Okay, we can always do that. Okay, and this is going to give us an idea of what this parent function is. So we're going to plug in to start 0. 3 to the 0 power equals 1. Now we're plugging in the y, so we get the x, which means we're putting that 1 in for the x. And this is going to be the point 1, 0. If we plug in a 1 or a 2, we're just raising the 3 to that exponent. So 3 to the first is 3. 3 squared is 9. Again, those are going in for those x's. So now we have the point 3, 1 and 9, 2. So far it looks almost like a square root graph. Now let's plug in these negative exponents. So if we raise 3 to the negative first, the 3 moves down to the bottom. We end up as 1 over 3. So if we plug in 1/3 for x, we're going to get negative 1 for the y. If we plug in 1/9 for x, we would get negative 2 for the y. That's these 2 points right here. And we can see what this looks like. Okay, it looks really similar to those exponential functions we did in section 7.1. This time, instead of a horizontal asymptote, we have a vertical asymptote. It's never going to cross that line x equals 0. There's nothing to the left of that where x's are negative values. That was the basic form of the equation. When it comes to transformations, we treat this just like every other function we've learned. There's a scale factor, and that's represented by this a that's out front, in front of that log. Okay, there can be a horizontal shift. It's going to move the opposite of whatever's next to that x. And then the number at the end is moving it up or down, and it's moving in the same direction as we see with respect to where it moves on the y-axis. So let's say we have this equation, y equals log base 3 of x plus 2 minus 3. Step 1 is to figure out what's the parent function for this graph. And the parent function is just based on whatever the log is. So this is log base 3. Parent function is y equals log base 3 of x. That's the one we did on the first slide in these notes. 3 to the y power equals x. Okay, we filled out the table for this already. We made the graph. It ended up looking like that. Okay, that would be our first step for this problem. After that, we're going to look at these two numbers here. So we have a plus 2 and a minus 3, and that's going to move it left 2, because it moves the opposite, down 3. So we take this red graph here, we move all of those points left 2 spots, down 3 spots. Okay, so left 2, down 3, left 2, down 3, on, and we get this new graph. Our asymptote moved over 2 to the left, just like the whole graph did. So now our vertical asymptote is at x equals negative 2. There's nothing to the left of x equals negative 2. Our domain is x is greater than negative 2. Here we have y equals 2 times log base 2 of x minus 3 plus 5. Parent function is log base 2 of x. That tells us that 2 to the y power equals x. Okay, so 2 to the y power would equal x. All right, if we filled out the table just like we did on that first slide, we're plugging in the y, so we plug in a 0 for y, we get 1. Plug in a 1 for y, we get 2. 2 squared is 4, etc. We would get this graph here. We're always going to do the scale factor second. So now we're going to take this red graph and we're going to make it twice as big. The y values double. Okay, so if we double this 0, it's still 0. Double this 1, we're at 2. This would become a 4. This would become a negative 2, negative 4. Okay, so it gets twice as big, and it ends up looking like this purple graph. And then lastly, we take a look at this shift. So it's going to move it right 3, up 5. So take that purple graph, move everything right 3, up 5. Right 3, up 5, on and on for all the points. and we get this graph right here. Vertical asymptote is at x equals 3. One last example, this one's going to look a little different. Y equals 3 times log base 1/2 of x plus 1 minus 3. Parent function is log base 1/2 of x. So 1/2 to the y power equals x. When we make the table here, okay, if we plug in a 0, we'd get a 1. If we plug in a 1, we'd get 1/2. 1/2 squared is 1/4. When we plug in negative values, that's going to flip that fraction. So plugging in a -1, for example, gives us a +2. Okay, so that gives us this red graph here. After that, we're going to deal with a scale factor. It's going to get 3 times as big. Okay, so this point ends up at -3. This one will be -6. Okay, if we kept going here, I have this other point, which is now at -9. All right, on and on. Okay, so 3 times as big becomes that purple graph, and then we move it left 1, down 3. Opposite, same. Okay, so all of these points, left 1, down 3, gives us this blue graph, vertical asymptote at x equals -1.